From the Plush South Studios in Livermore, California, this is Mr. Meyer and 12.3 Arithmetic Sequences in Series. So what are we going to talk about now? Arithmetic sequence. You've been dealing with sequences or lists of numbers, and now we're going to talk about a special kind of list, a list where they add the same number every time. When they add the same number every time, that means that it is what's something called arithmetic. So when they add the same number every time, it is called arithmetic, and there's some special formulas which you can see right there with the general rule and the sum. But I'm going to first talk about, how do you notice? So look down at this first example, and it says, all right, here's a list of numbers. Well, I can see that we added 6 to get here, and I can see we added 6 to get here. I can see we added 6 again, and I can see we added 6 again. So we are adding 6 every time. And when we do that, we say that that is an arithmetic sequence. So I would say, yes, this one is arithmetic. This is arithmetic. And what's important about that is that you can tell me what they're adding every time. That's called the common difference, D. So we'll say D is a 6. That's the difference, because you would usually subtract 1 from the 1 in front of it. So like 8 minus 2 would get you 6, or 2 minus a negative 4 would get you 6. That's how you would find it. You would usually do a term minus the 1 in front of it to see if they have a common difference. And then I'd ask you probably what the next term is. Well, you would know the next term is 20. So next term would be 20. And that is how we deal with arithmetic sequences. And the cool thing is, we can just make an equation. You know how explicit equations are kind of tough to come up with? Well, we can make one just if you notice it's arithmetic, because all you have to do is take the first term and then just keep adding that common difference however many times you need to. And that's all this formula up here says about a general rule. It says, hey, look, your rule, if you have to make a rule for arithmetic sequence, just tell me the first term, A1, and then do n minus 1, leave n alone because I don't know what term the people want to find, times d, the common difference. So however many times you want me to add that difference, I will. And that's the formula for an explicit form of an arithmetic sequence. Now let me see, the next one looks like they subtracted 3, which is fine, but then they subtracted 6, and then they subtracted 9. Yeah, this definitely does not have a common difference here. So therefore, I can't say they did. It does have a common second difference, which means it's quadratic. So these would be like, this would mean it's linear, and it's not. So then if you want to check if it's quadratic, you do a next common difference. And look at that. If I do negative 6 minus 3, and then 9 is, well, sorry, negative 3, and then negative 3, and then negative 3. Ooh, it's quadratic. But they just said determine if it's arithmetic. So no, it is not. That first one, the linear one, is not. So this is not arithmetic, but if you want to get ahead of yourself, go ahead and say it's quadratic. Arithmetic. So I can't find a common difference. And that's how you tell if something has a common difference, right? Or if it's arithmetic or not. There's also a formula for the recursive. That's pretty easy. You just say always, always, always an equals an minus 1 plus the common difference, and make sure you tell people what the A1 term is. So you got to make sure you say that. There's also a formula for summing this, which is, I'll show you in class, was thought up by Gauss. And it is the first number plus the last number in the list divided by 2. And so now let's go ahead. I think there's an n missing in that formula. Yeah, there is. This formula is bad. It's the sum is the number of terms over 2, the first one plus the last one. My bad. Sorry, I had a little typo there. Or you could move the 2 to underneath where it was there and just multiply by the number of terms, but I did forget to multiply by n. So that is your formula. So be uber careful when we use it, and I'll show you when we use it. So here it says find the 12th term. So you got two options. You can either write out all 12 terms, or you can say, oh, wait, it's arithmetic. I can make a formula. The formula, or the explicit formula, is the first term plus n minus 1 times d. And I can tell you guys the first term is 20 because I can see it. And n minus 1 times d, what are they doing every time? It looks like they're subtracting 6. So it looks like a negative 6 is d. Well, I can clean this up a little bit. 20 minus 6n plus 6, or a sub n is 26 minus 6n. That formula will get you any term, not just the 12th term or the 10th term. You'll find any term you want as long as you tell me what n is. So for this problem, they want n is 12. So I can tell them. I can be like, well, that means that you're going to take 26 and minus 6 12 times. And so what would that be? 60, 72. So 26 minus 72. That's a whole lot of negatives. What is that? 46, I think. So, oh, wow. Or -6. Yeah. -46. And you will have your answer for the 12th term. All right. What about finding the missing terms of a sequence? Very simple to do too. We will just call this the first term. And then this is the second term, third term, fourth term. This is the fifth term. And so if I want to figure out, in this case, what's missing in between there, I go, well, I use the same formula. A sub n is equal to a1 plus n minus 1 times d. And I plug in the things I know. Like I know the first term is 17. And I know the fifth term is -7. So that means when you plug a 5 in for n, you get the fifth term, which would be, in our case, -7. That's a little tricky there. But what is that? That's -7 equals 17 plus 4d. And now I can move the 17 over and get -24 equals 4d. And then divide by 4, and I get -6. So they are subtracting 6 every time. So now I can build the list. 17, and then I'm going to subtract 6 is 11, and then I'm going to subtract 6 is 5, and then I'm going to subtract 6 is -1, and then I subtract 6 again is -7, and you can see that list is exactly what they wanted. Wow, that was a lot of info for one equation so far, and maybe I'll do it one more just because I might be able to sneak this in. So here we go. Again, a sub n equals a1 plus n minus 1 times d. Again, they told me some terms. Now, this is a little trickier because they told me the 8th term and the 14th term. So that's a little different. I might want to rewrite this, right? I might want to call 85 the first term. Now, why would I want to do that? Just so I could use the formula. So it's going to be 85. That's the 8th term, 9th, 10th, 11th, 12th, 13th. And now the 14th term is 157. So what is that in my new list? A1, A2, A3, A4, A5, A6, A7. So now I can use that same formula. I can say, oh, look, 157 is just 85 plus n minus 1, 7 minus 1 d's. And now I can solve for d. So I can say 157 is 85 plus 6d. I can subtract the 85 and get, what the heck is that, 72. So 72 is equal to 6d, which means that divide by 6, and that'll be, I think, 12 is equal to d. So they are adding 12 every single time. So if you wanted the next number, it'd be 97. If you wanted the next number, it'd be 109. Awesome. But they didn't ask for that. They asked for the fifth term. So now let me get rid of these things again. This is now, again, the 14th term. This is now the 8th term. That means here's 7, here's 6, here's 5. I want this guy. So one way I could do that is I could now subtract 12 and get 73, subtract 12 and get 61, and subtract 12 and get 49. And so there's your answer. The fifth term is 49. Now there's many ways to do this problem. Another way I could do it is using this formula, finding the first term and I figured out what d was. And now once I figured out the first term, I could tell you any term in the list. So kind of a neat situation. All right, let me ask you a question, and I'll be right back after this. All right, nice work. Now let's move on to summation. Now, summation is a little different, right? That means we're going to add up the entire list of numbers. So here in this next example, you can see that what they're asking us to do is to sum up the first 18 numbers in this list. Now, you might notice that's bad news because we only have 1, 2, 3, 4 numbers. So we don't even know the 18th number. So how are we going to add them all up? Well, again, you could write out all 18 numbers, or you could use the formula. Now, the formula goes like this. It's the sum of the first 18 is the number. I guess I should do the formula first since it was kind of gross up there. So sum of the n numbers is the number of terms over 2, the first one plus the last one. So we have it kind of nice. We're like the sum of our first 18 is 18 over 2. The first one, 13 plus, oh, poop. We don't know the last one, right? So let's go figure it out. We know how to find the net term. Let's just use the explicit rule. So the 18th term would be the first term plus 18 minus 1 times d. That's a grade 18. So that would be the first term, 13, plus n minus 1, we said is 17, times d, which it looks like they are doing what? I'm not sure. 2 minus 13 is negative 11. They're subtracting 11 every time. So what do I get when I do that? Sheila, help me out. 13 plus 17 times negative 11. She says it's negative 174. So this is negative 174 is the 18th term or the last term that we want to add up. So we're going to put negative 174 right here. And that should now sum up the formula. I have a 9 and then what, 13 and 174 was that negative 161. And if I multiply 9 and negative 161 together, I'm going to ignore the negative because I know it's negative 1449. So negative 1449, if you add up the first 18 terms, that would be what you get. Nice work. All right, what about this other one? Written in the sigma notation, which scares everybody, right? Well, the first thing is I don't know that it's arithmetic. Well, they told me it was, so I do know. But I don't know what the common difference is. I don't know what the first term is. I could probably figure out the first and last term. In fact, it should be pretty easy. To figure out the first term, you plug in a 1. So you'd get 5 plus 2, which is 7. To find the last term, you have to plug in a 15. So that would be 5 plus 2 times 15, or 35. So I know that the first term is 7. I know the last term is 35. I know there is 15 numbers in this list. So, man, this is going to be beautiful. The sum of the first 15 is 15 over 2, the first one plus the last one. And now I just need to solve that. Now, this is one of those times where I'm going to move the 2 to the other side. I'm going to do 15 and then 7 plus 35 over 2. Now, some of you might be saying, whoa, 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 how is that legal? This is multiplying by half, and multiplication doesn't really matter what order you do it in. So let's see, 7 plus 35 is 42. So that's 15 times 42 over 2, which is 15 times 21, which is 300 and something, right? And so let's make sure that we got 15 times 21 is 315. And whoa, what did I just go? Total is 315. That is the sum of the first 15 numbers in that list, even though I don't even know the 15 numbers in the list. I only knew the first and the last, and I was able to sum them all up. All right, last problem. There's a concert hall with 15 seats in row 1. They have 15 seats. They add 2 seats to the next row, so now there's 17 seats. Then they add, 2 more seats to make 19 seats. How many seats are in row 20? So if this is row 20, how many seats are there? So this was row 1, row 2, row 3, all the way to row 20. You might notice that's just a sequence, right? 15, 17, 19, dot, dot, dot. I could definitely tell you how many are in row 20 because they're just adding 2 every time. So the 20th row would have the first row plus 20 minus 1 times the common difference 2. So 15 plus 19 times 2, 15 plus 38. What is that? 53? 53, I think. Yeah. 53 seats in the last row. Boom. Now, how many seats are in the first 20 rows? In other words, let's add up all 20 rows. So here you go. Sum of the first 20 is 20 over 2. The first one, 15, plus the last one, 53. This is how many seats are in those first 20 rows, or 10 times 68, so 680 seats. And so I guess I should do a better job of using units. So I will say down here, 53 seats, so people know what I'm talking about. All right, that's it. Have a great day. Stay happy, and I'll see you tomorrow.